This is Chapter 1, Section 1 notes, and we're going to start with a little bit of vocabulary. So the first vocabulary word is quantity. It's anything that can be measured or counted. For example, these can be marbles, cows, people, any lengths. Anything that can be measured or counted is quantity. The next vocabulary word is variable. Variable is a symbol, usually a letter, that represents the value or values of a quantity. The three common examples that we'll have are X, Y, and N. Any other letter of the alphabet, though, will work as a variable. Algebraic expression is a sentence in math that contains at least one variable. So something like 3x plus 4, or just as simple as 2y, as long as it contains at least one variable, it's going to be an algebraic expression. Next, we have a numerical expression. This is a sentence in math that involves numbers, but not variables. So you might have 12 plus 7 divided by 3, or 27 times 4. All of those mathematical sentences do not have a variable, so they're called numerical expressions. Next, we'll start with some actual guided practice problems. So this first one, letter A, we're just translating from the English sentence to a math sentence. So it says 32 more than a number n. More means you're going to add. The than actually switches these two around. So it flips them. So instead of 32 plus n, it has to be n plus 32. Because of that than, it switches or flips those two around. It works the same way with subtraction. So 58 less would mean subtraction, but the than flips the order of those two, a number n. So I have to start with the n, then subtract the 58. So n minus 58 should be my mathematical sentence. Number 2, multiplication and division. 8 times a number n. So this could be written as 8 with an x in between n, or it's more commonly written just as 8n. 8 times a number n. Letter B, the quotient. Quotient means division of a number n and 5. It goes in that order because n is first, n goes on top. So n divided by 5. Remember, fractions are just a different way of writing a division problem. Number 3 says 3 more than twice a number x. This is getting a little bit more complicated. So 3 more means add, but the than is going to flip the order. So it's going to be plus 3 at the end. Twice is 2 times a number. So 2x is going to be first. So 2x plus 3 is my mathematical sentence. Part B starts out with 9 less than. So my minus 9, because of the than, has to go at the end. So minus 9 at the end. The quotient, so that's division, of 6 and a number x. Again, 6 comes first, so it'll go on top, divided by x. So 6 divided by x minus 9 is my mathematical sentence. Letter C, the product is multiplication, of 4 and the sum of the number x and 7. So you're taking 4 times the sum of x and 7. So you'll do 4 times and then x plus 7. That goes in parentheses because we can also write this as 4 and then just x plus 7 in parentheses. Okay, so we can write it as if it was going to be a distribution problem. 4 times the sum, or the addition, of x and 7. So now we're going to go the other way. So using words to to write out what an expression is. So now we're translating from the mathematical sentence to an English sentence. So for this first one, it is x plus 8.1. So I could write x plus 8.1 in the English. I could do the sum of x and 8.1. I could do 8.1 more than x. Okay, so I have multiple different answers. So here are the ones that I found. Now, if you want to do different ones, again, that's fine. So my first one, I just did x plus 8.1 because that's how I would read the problem. So I'm just going to translate it into English just like I would read it. The next one, I might read 10x plus 9. So 10 times x. I'm actually going to change this from more than to plus because that's how I read it. Plus 9. This next one, because it's a division, I would say the quotient, so the division of n and 3. So the quotient of n and 3. You might say n divided by 3. Okay, either one of those would work as an answer here. This next one, I could say 1 less than 5 times x. The less than, again, flips the order, which is perfect because the minus 1's at the end, and then 5 times x is the 5x at the beginning. Okay, so we've done a lot of translating, both from math to English and from English to math. So the next sentence, or the next part, is just describing a rule. So a rule is just a pattern that's happening in mathematics. So this says, Julie is moving into an apartment. She needs to rent a truck. She pays an initial $49. Every mile she drives costs her an additional 75 cents. Write a rule in words as well as an algebraic expression for the total cost. So this starts out with this table. So the table is already given to you. If she drives 1 mile, this is how she calculates the cost. If she drives 2 miles, this is how she calculates the cost. Now you'll notice that this equation for cost stays the same. So 49, 49, 49, and 0.75, 0.75, or 0.75. This is the only numbers that are changing each time. So when I'm writing a rule, I'm going to change the numbers that keep changing into variables. So if I want to find out any number, so n, number of miles, I can just say, okay, $49 plus 0.75 times n, the number of miles. So that's going to be my mathematical expression. And then I just have to translate this into words. So $49 more than 0.75 times the number of miles n. And that's it. So you write your expression, then you translate it into words. The next sentence says, well, how much would the truck cost to drive if Julie has to drive 37 miles? So this means that our number of miles, the n, is 37. So I'm actually going to use the equation from the previous problem, and I'm just going to plug in 37 for where n was. So $49 plus 0.75 times 37, if you put in your calculator exactly like this, putting in parentheses and all that good stuff, you should get $49 plus $27.75. So that's a total of $76.75.